Hello, everyone. My name is Volodymyr Agafonkin, but you can call me Vlad. I'm a Ukrainian engineer in Kiev, and even though I'm gonna give a talk in the middle of a large-scale war, today I want to talk about life, because after all, this is what Ukrainians want the most, to just continue having their normal lives and do everyday things that they love and spend their time with their families. I'm most known in the engineering community as the creator of Leaflet, a small JavaScript library for interactive maps, which is now an industry standard. And for the last 8 years, I've been working at Mapbox, building mapping tools of the future, and in particular, a state-of-the-art vector rendering engine called Mapbox GLGS, which is a very difficult and complex project involving a ton of computational geometry, computer graphics algorithms, and data visualization techniques. So today I want to talk to you about data visualization, but not in the context of work. And I'm going to start with spreadsheets. I'm sure most of us have used spreadsheets for some personal things. Here's an example of a spreadsheet from my account, which is a recipe for panettone, a traditional Italian pastry. And spreadsheets are simple and familiar and easy to work with for personal things because you put in some numbers in the cells, like a flour amount here, and you can reference other cells for some calculations, like the ingredients here. And you can easily use formulas like summing all the ingredients to get the total amount of dough, and even generating some charts from this data. But imagine that there existed kind of a spreadsheet, but instead of those formulas, you could enter arbitrary JavaScript, and instead of text data, you could have any kind of web things like canvas drawings, HTML elements, even WebGL visualizations. And this tool exists, and it's called Observable. Observable is a tool for data visualization and a development environment for exploring data. And I use it very often, both for work challenges and for personal things. Since I'm working in a very visual field, so with maps are a visual thing, I have to deal with algorithms, and exploring visual algorithms in this kind of environment is just perfect because you can write some pieces of code, you can use them interchangeably, you can drag things around. And here you can see some markdown content for description. You can see a cell with code that generates some test data for visualization, boxes of random size. And then you have the algorithm that tries to efficiently pack them into a sprite layout. And also a cell that uses ordinary 2D canvas to draw the results of the algorithm. And we can animate it easily, so we can explore how it works and adjust it. You can do much more advanced kinds of visualizations because you have the whole power of NPM at your disposal. I can import any kinds of libraries like ZDoc in this case. I'm defining some functions, defining some data, and generating this visualization of a 3D space filling curve, which I can explore, drag around, and I also have this cell with a input range HTML element that can parameterize this visualization for me. And here's one more example with WebGL. So I worked on an implementation of this algorithm that generates triangular meshes for a sphere. And I imported Three.js. I set up some scenes with some lights, and I worked on this algorithm, and finally I'm displaying this element here, and I can freely explore it and drag some sliders around. It's a really nice way to develop things visually. The most advanced kind of algorithm that became viral on online and got on the front page of Hacker News that I wrote is Martini, an algorithm for generating simplified terrain meshes for terrain. And here's another algorithm where I'm exploring floating point errors when used in computational geometry algorithms, which look kind of like art. And here's another algorithm that I worked on that generates an outline of an arbitrary set of points. And besides these kinds of algorithms, I'm also using this tool for debugging. Like I had an algorithm for texture mapping a sphere, which acted in a buggy way, and I explored it for a long time, changing the code here, trying out different things, and finally settling on a set of fixes so that it could look like I need it to look. Here's another example of picking the right parameters to place labels on states. Here's a very simple notebook that I made to just paste some geometric data and then be able to see it and explore the edges one by one. Just a very simple thing, but very useful in some cases. Here's a custom visualization of a performance profile I made because I needed customized for some things. And one more example where it was easier for me to programmatically in Canvas draw this kind of illustration for a blog post that I wanted to write than to draw it from scratch in Photoshop. So when you're doing these kinds of things for work, eventually some of the skills that you develop, some of the mindset start to spill over to other parts of your life, not just work. And my favorite example of this is a parking challenge that I had 2 years ago. So 2 years ago, I got a driver's license. I've never driven a car before, and I just started driving. And some of you may know that it can be a very daunting task, and one of the most difficult parts of being a beginner driver is knowing how to park a car. So we had a reserved parking spot near our apartment, and it was in a very tricky place. So there's a system of parking very popular in Europe called reverse angle parking, where you drive with your car and then you back down and diagonally get into your parking spot. In my case, the situation was complicated by the fact that the road width was extremely narrow. It was a one-way street, so I could only go here like this and then back down into my spot. And another complication is that the parking was almost always full, so I had to make sure not to hit the cars on the left and on the right. And also, when you're backing down and turning at the same time, it was very hard not to hit those bollards that you have on the right, because car starts moving slightly right when you're backing down and turning. And I wasn't even sure that it's possible to to park for me in these kinds of super constrained situations. But I knew that there's one tool in my disposal that I can try to apply to solve this problem. And this is mathematics. I decided that I can make a mathematical model of the parking spot that I have, and also take a mathematical model of a car that is moving through space, and see if it's actually possible to park in this situation. So I took a tape measure and I went outside and started measuring like the width of the road, the width of the parking space, the angle of the parking spots, and I entered them in my observable notebook as constants. So I had these parking dimensions, I wrote some simple canvas code, and I had this visualization. So now I have a model of my parking spot. So I'm moving like here, and then backing down to this parking space. Now the next step was to make a mathematical model of my car and how it moves. So I started Googling like mathematical model car movement, and I landed upon the so-called Ackermann steering geometry, which is an approach to designing like steering wheels that was invented for carriages a century ago, but is still used in pretty much the same way in modern cars. And you can model it with math and JavaScript pretty easily. So and also stumbled upon this article that explains all the math, and even has this interactive car that I can steer and drive around. So I took this code and these formulas, and the last piece of the puzzle was Googling my car model and taking the exact measurements of the car width, the car length, the wheelbase, and all those stats that I needed to know how the car will move in this space. And after I entered all the constants, I wrote some more canvas code and landed on this visualization. And now I had a kind of a car as a rectangle, and I had a kind of a trajectory that showed how I'm backing into my parking spot. And I also added this kind of input to see how much steering the wheel would affect my trajectory. But this wasn't enough, because when the car backs down, I could easily hit the obstacles here. So I needed to show the coverage of the car moving through space. So after some more mathematics and canvas crunching and some more fiddling with parameters, I landed on this model that shows how the car moves as it backs down into the parking spot, and while having the wheel turned to the max. And after playing for a while with this model, I settled on a specific strategy, how I could park my car with a simple algorithm. I would drive, I would stop when the next line after this my parking spot aligns with my head, and then I would turn the wheel to the max and back down. And the car would just slip into the spot in a perfect way without hitting anything. And 2 years has passed, and to this day, I use the same simple algorithm that I derived from this mathematical model. So if I didn't do this visualization, I don't know if I could park there, but this helped me tremendously. Let's go to some other examples of visualizations in my personal life. So I'm an avid baker, which you may have figured out if you follow my Twitter. And I'm really deeply into this stuff. And here's an example of a sourdough loaf that I baked. And this is another one with walnuts. So I'm baking regularly, several times a week. And to help with this baking, because it involves a lot of percentages, involves a lot of math when you're trying to come up with your own recipes. And I made this notebook, which is very simple. It has some formulas for ingredients and a bunch of HTML forms. And I can just decide that, for example, I want to bake baguettes today, and baguettes are 250 grams. I want to bake two baguettes, so I'll bake 500 grams dough total. Baguettes are usually 72% hydration, and I don't have too much sourdough starter left, so I use 30 grams. And by entering a few details here, I already know what to use in my recipe. How much flour to use, how much water, how much salt, and approximately how long it will ferment. Now, as I started going deeper in the baking scene, I started attempting more difficult pastries. And one of the most difficult things to bake for a baker, for a home baker like me, is croissants. Those are also croissants that I made myself. And croissants are very difficult because you have to make a special kind of dough called laminated dough, where you take a piece of butter, you fold it into the dough, then you roll it, and you fold it multiple times. And fold and roll multiple times until you have these kinds of layers that give croissants their amazing structure and texture. So I decided to explore how these kinds of folds that we make to the dough affect the structure, because there are many approaches to how you fold this dough. And I made this laminated dough calculator. So there's you can fold butter in a French way, you can fold it in an English way, and you can do different kinds of folds: a book fold, a letter fold, a single fold. And one thing that I derived from making this notebook that no one covers on YouTube and recipe books and instruction manuals is that when you're using a French fold, you have a perfectly regular and consistent layers. But when you're using English folds, then the layers won't be consistent. Some will be wider than the others, and there's no one told me that, but mathematics don't lie. The next category where visualizing data is really helpful is fitness. So I've been strength training for quite a while, and I'm using this website called Strength Level to enter my sets, like how much weight I pulled or pushed, how many reps, how many sets. and it draws some charts like this, where you can very easily see that when I'm training consistently, like going to the gym 3 times a week, I'm making rapid progress. But as soon as I start doing huge gaps in training, then my strength level drops dramatically. So I decided to kind of motivate myself to train more and build custom visualization for my training. And I built this visualization called Workout Consistency Heat Map. So here every row is a year, and these blocks are months, and every white dot is a training session. And from a lot of research, we know that after we trained, we have 48 hours while our muscles are recovering and becoming stronger. Then after 48 hours, it evens out, and then 2 days is an ideal interval between trainings, because you will constantly push your muscles towards improving. But when you make much bigger pauses, like a week, your muscle strength starts to fall again. So I decided to visualize this with color, because humans in general evolved to understand and make sense of colors and shapes and relative sizes. And this is why visualization is so helpful, because we're not evolved to understand and make sense of numbers easily. We can understand them when we can see them. So here we can see some periods in my life when I try to train consistently. I think this period with everything green, that means that my muscles constantly improved, is when I built this visualization, and it kept me motivated for a while. But then, you know what happened? The pandemic. The gyms closed, and it started falling down all over the place, and started becoming super inconsistent again. I tried to, I had some injuries, and then I had some periods on and off, and finally I decided to start training consistently once again this year. And then the war started and gyms were closed again. So no luck here, but I hope that I'll continue motivate myself like this when gyms reopen. I have some more notebooks about fitness. So here's my spreadsheet for how much weight I should do for bench press, overhead press, squats, and deadlifts and rows, and like my schedule through the weeks and my goals. And I could do this in a spreadsheet, but I'm so used to this environment that it's much easier to write up some HTML and make this customized spreadsheet. And I can use JavaScript to customize it further. For example, here I'm rounding it to the smallest plate that I have in my gym, which is very convenient. And one more notebook where I'm exploring different formulas for so-called 1 rep max, where imagine you can do an exercise for 5 repetitions max. How much more weight can you do for 1 repetition? And there are many formulas to calculate this kind of thing, which is very helpful when planning training. And I've, throughout many papers and articles, I found a dozen and compare them. And you can drag the number of reps around and see how different methods compare, which is very interesting. For someone who is into strength training. And one more thing, also related to fitness, is so my iPhone, it tracks the number of steps I make every day, at least when I have it in my pocket, which is almost always. And it tracked this data for quite a while, and I decided to visualize this data, how many steps I make every day, and try to get some kind of global trends, like to see whether I would walk at some years more than the others, and see if there are any interesting patterns. So here you can see steps visualized for 8 years of my life. And when I look closely, there are many interesting things here. But one interesting is that obviously when the winter comes, or at least the rain season in September, October, I start walking much less. So the activity falls. So there are colder colors here, as you can see. And then you can see this kind of terrible trend. And obviously this is the consequence of the pandemic. So when the pandemic hit Kiev, for the first 3 months, I pretty much stayed at home all the time. So I almost didn't do any activities. Then it started recovering a little bit. But what I discovered from this visualization is that it never recovered to previous levels, even though I adjusted and feel like I'm mostly back to my previous life, at least locally. And that means that I have to do something about it. And also you can see that when the war started, my activity also wasn't great. So I have to start walking more and running more. So yeah. Next, I want to show you some visualizations that are not related to fitness, but are still personal and interesting. So I had this feeling, like trying to remember my childhood, that we had much more snowy winters when I was a kid than we have now. And like, obviously it can be explained as climate change, but I wanted to check if it's actually true, because snow is a big deal for me. I'm really into snow activities, and especially as a child, I absolutely loved snowballs and sledges, and I couldn't wait until snow falls to go outside. So, and there's also one special memory I have when I was a little kid, and it was my birthday. And my parents said that you make a wish and you blow the candles on the cake and your wish will come true. But already then I knew that this sounds fishy and my parents are probably lying, and I'll prove them wrong. And I decided to make a wish so that there's snow falling. And there was no snow, and my birthday is on November 20. It's usually when it starts to snow, or it should. And I made my wish, I blew the candles, and immediately I looked at the window and there was no snow. And then I cried and made a tantrum. So I remember this very vividly. And I also remember that the next day when I woke up, everything was white. There was a snowfall through the night, and my birthday wish came true. So I decided to find out when it happened, what age I was, that I remember so vividly. So I made this visualization. I found the data of snowfall coverage or snow depth on the ground for the last more than 40 years in Kiev. And you can see all kinds of interesting things here. So the hotter colors mean more snow. And one interesting exploration here is I discovered that the birthday wish snow was in 1992, and I was 6 years old. So that I know for sure from this visualization. I was also surprised to see how snowy 2012 have been in Kiev. It was completely crazy. And also, it turns out that my childhood winters weren't as snowy as I remember, and that I had plenty of snowy winters later in teens and as an adult as well. Here's one more visualization, kind of simple, may be useless, but Amazon unfortunately doesn't give you any kinds of data for reading an electronic book like Kindle. But it has this feature where you can request all the personal data Amazon has on you. They will process your request in like 2 months and send you everything they have. And this is required by law or something. So I requested this data just to scrape the Kindle data of how often and how fast I turn pages on my Kindle, and made this histogram, from which I learned that my average reading speed is 30 seconds per page turn. Here's one more notebook that I found in my history, but I can't for the life of me remember why I made it. So I measured all the angles of my balcony outline, including a building opposite of the balcony, and I plotted the path of the sun going through it to know when it's shining in my balcony. And I don't remember why, but it's still cool. And by the way, you can see here that you can reuse code from different notebooks. So I made this notebook of sun position, and I imported this function in my other notebook for the balcony. So another one, very silly. Since the invasion started, European Union has been more united than ever in the response to this war, and giving incredible support to Ukrainian people. But before the invasion, the politicians in the EU were kind of a meme in Ukraine, where their reactions were mostly limited to expressing different levels of concern. And there's this famous Twitter account called Is EU Concerned, which tries to capture all expressions of concern by EU members. And I decided to scrape this data. I scraped 1,000 tweets from this account, I parsed it, and I generated some statistics, and I discovered that EU has been concerned in the last years for 212 times. It has been deeply concerned for almost as much, and it has been gravely concerned for 16 times. So it's I don't know how useful is it, but it was fascinating for me to learn. And this is the kind of silly stuff that you can do with data visualization and scripts. And one more example, Wordle. Everyone plays Wordle now. But we have a Ukrainian version of Wordle. And while the English version of Wordle has been mathematically and scientifically researched to the brim, and of course, everyone knows the best words to start the game with, like crate or list. But Ukrainian version of Wordle, no one did the math research, and so I didn't know what word to start when playing. And so I decided to make this notebook with all the words in the Ukrainian version of the game and kind of try to get some good words to start. And now I have some good words. One of them is karta, which means map, which is very fitting for someone who works on maps. And finally, my last personal visualization that I want to talk about. When the war started, we fled Kiev because there were airstrikes, and I didn't want my twin daughters, to experience this. I wanted them to be safe. So we fled southwest of the country, where it was relatively safe, but there were still regular air raid sirens, which means that rockets were still flying above and could hit anywhere in the country. And so here's a collection of photos I made of my girls sleeping in a bomb shelter. Now they're safe. They're in Poland while I'm here in Kiev. And after a few weeks, after my family left to safety, I really wanted to go home. And I needed to make a decision of when to come back. And it's very hard to make these kinds of decisions. There are all kinds of factors in play, but one of them is the level of danger from air attacks. And I decided to help me make the decision of when it's relatively safe to come back to Kiev. I decided to make a visualization of air raid sirens. So we have this Telegram channel which posts air raid sirens when they go off in a particular region and when they stop. And there's an accompanying app for mobile phones which helps us track this and get to safety when it happens. So here are the first few weeks of air raid sirens in Kiev. You can see how many of them there are, and a lot of people had to sleep in halls or in bathrooms or underground in metro stations. But you can see that I published this on April 7th. And here is April 7th. And this is where air raid sirens started to die down a little bit because Russians started to lack rockets. They're not infinite. So they started to be more selective into where they hit. And specifically in Kiev, especially after they withdrew their troops there after a failed capture and siege attempt, it started to be more safe. And I watched, after I made this visualization, I watched it for several days, and I saw that it should be much more comfortable. And this visualization helped me make a decision to come back. So here I am in Kiev and making this talk for you. And even though my family is not with me, I hope they can return soon. But meanwhile, it's much easier to deal with this when I'm home and I have all my favorite things at my disposal. But no, not everyone is as lucky here. So, for example, Kharkiv Oblast, which is on the front line, you can see that it's a complete nightmare. So that was my last visualization to share with you. Thank you for listening, and thank you for all your support and donations. And feel free to ask any questions. I'll be here.